In this video, we look at the two-class concentration-based sampling plane, assuming a log10 normal distribution using the calculator in the two-class concentration tab. There are several areas in this calculator, and cells which allow user input are shaded in orange. At the top, we have an area for specifying the sampling plane, including the sample size, the acceptance number, the standard deviation on the log10 scale, and the microbiological limit, little m, also on the log10 scale. The corresponding OC curve for this plane is shown at the bottom. There is also an area for the point of interest, which allows you to calculate the sampling plane's probability of acceptance and rejection for any mean log10 concentration that you might be interested in. And there is an area for providing the consumer's and producer's risk point, and there are several additional graphs on the right hand side that provide some extra information, as we will see later. So as an example, let's consider Annex 2 to the Codex Guidelines 61 on Listeria monocytogenes, which contain a microbiological criterion with n equals 5, c equals 0, and a microbiological limit of little m that is 100 CFU per gram, which equals 2 on the log scale. Now let's also assume that the standard deviation is 0.6. The OC curve is shown at the bottom here for this particular plane, and we can now calculate the probability of acceptance when the mean log10 concentration is, for example, 1 on the log scale. Assuming, of course, that the standard deviation remains at 0.6. We can see from the various outputs here that the arithmetic mean, which is calculated from the standard deviation and the mean on the log scale, is 26 CFU per gram, and that there is almost a 5% chance that an analytical unit from this particular food lot would exceed the microbiological limit, little m. In addition, this particular sampling plane with n equals 5 and c equals 0 results in almost an 80% chance of accepting lots with this particular mean concentration, and the corresponding point is also shown on the OC curve. The three graphs on the right hand side here show some additional information that you might be interested in. The first plot shows the normal distribution with the specified mean concentration of 1 and the microbiological limit of little m. The second graph shows the proportion, this proportion here, of analytical units that are expected to exceed the microbiological limit for any particular level of mean concentration. So if we change this to 2, we see the two curves changing. In addition, we have the last graph here, which also shows the OC curve, but using the log10 scale and plotting the mean on the log scale. We've provided this to allow you to compare your results with some other published texts which use this particular OC curve rather than the one with the arithmetic scale. Now we can also use this calculator to find the mean concentration which, under the current sampling plane, results in a low probability of acceptance, for example 5%. We can find this by changing the value of the mean log 10 to something a bit higher, such as 1.5. The probability of acceptance drops to 32%. Now we need to go a little bit higher. Let's go 1.9. We're getting close to the 5%. 1.91, 1.92, 1.93, and at 1.93 for the mean on the log 10 scale, this particular sampling plan would result in a probability of acceptance that is just below 5%. So you could use this calculator to evaluate the effects of a sampling plan in relation to the mean concentration for any particular process or situation, provided you have an understanding of the variability in the food product that you are sampling and testing.